Good afternoon and welcome to all of you to this 4D BIM Masterclass webinar that is being conducted by PKC Consultants, a fast-growing organization in BIM and 4D BIM services and also project management consultancy services. Little about me, I have been in the industry about more than 3 decades now, and last 2 decades, very deep dive into the infrastructure and construction life cycle technology solutions like geospatial, CAD, 3D BIM, uh, 45D BIM now, and asset management and O&M solutions, spanning across sectors which could be real estate, heavy civil, um, transportation like roads and highways and airports, oil and gas, and power. And over the last 20 years, I've led businesses at a country level or at a regional level at ESRI, which is the world's biggest GIS company, Autodesk. Everyone knows Autodesk for its Revit and AutoCAD, Hexagon, Dassault Systems, and of course Bentley Systems. So as you can see, these are all leaders in their own fields as far as infrastructure design and analysis and project management is concerned. So I bring that experience, and over the last 2.5 years, I have been working as a consultant, engaging with GKC, with all the clients, and helping them choose the right kind of technology in terms of assessing where they are, and then recommending the right technology and helping them implement it. Uh, Next slide, please. All right. So the reason why we wanted to talk about the technology trends in construction before we jump into the 4D BIM per se is that there are a lot of new technologies which are coming into the foray for people to adopt to increase their productivity, efficiency, reduce cost, and be able to deliver the projects on time or even before time and keep the customers happy essentially. And for all of you, you may have come across some of the trends that I'm going to talk about, or maybe contemplating, or may have just about heard it. So I'm going to give you a quick walkthrough of some of the trends that we are observing. So the first one is, of course, building information modeling. Not really a recent trend. It's been in the marketplace for almost 20 years, as I know. But I think it's now catching up pace. People have started moving from 2D CAD drawings to a complete 3D and BIM model. So just to clarify, one misconception that many have is that BIM is not a software. For example, some people equate Revit with BIM. It's a process. It's a process by which you can build a building through a virtual model before you actually physically construct it. And the biggest advantage is that you make a change somewhere, that change gets reflected everywhere in the model, which is a amalgamation of various disciplines like architecture, civil, structure, MEP, and so on and so forth. And of course, now we have a globally accepted ISO 19650 standard, which was earlier called PAS standard. So there are clear guidelines as to how you implement. So, for example, when you're creating a BIM execution plan, you keep in mind these guidelines. And some of the tools that we usually use, as you all know, are Revit, probably the most popular tool, Civil 3D for your transportation design, MicroStation, Open Road Designer, specific to road and highway design, Open Building Designer, Open Rail Design, and so on and so forth. And of course, you also have products like STAD, etc., ETABS for structural analysis. So the list is endless, and there are many tools, there are many products available. And the best part today is that they are all interoperable. There are open standards. You have IFC also, which helps you to interoperate all the data between various tools as you move through the construction life cycle maturity. Next slide, please. All right. So some of the benefits, again, this might sound a little repetitive to you, but nonetheless, so I think the biggest example is the biggest benefit, I'm sorry, is the digital integration part where you can actually streamline or collaborate with the entire ecosystem across all the team members and stakeholders in a multidiscipline design format. And it's a single platform to comprehend the complete design, visualize it, including all the floor plans, elevations, and 3D models, right? It is cost effective because you're able to do clash detection at different levels. So you're able to get a clash free design which will essentially help you in better construction management and help you avoid all the. Can you go back to the previous slide, please? Yeah, thank you. And also help you to avoid any delays or rework at the construction site. And moreover, it also helps you to reduce duplicate documentation, which gets and basically prevent the chaos that may exist between the different stakeholders, the architects, the MEP consultants, and the structural consultants, right? And the BIM process is completely coordinated at every stage of the design and as we move into the construction process workflow. So the design is aware of the latest version of the design model or the model per se, and the change management becomes very easy and effective. In terms of productivity, as I mentioned earlier, a coordinated BIM model will have all the information. So when we say building information modeling, essentially the key word is information. So as we design buildings or any kind of structure, the information pertaining to the model is there across all the disciplines. So basically all the information regarding every change that you make in the design, and everyone will have access to that change. Okay. And essentially it results in higher productivity, lowered costs. So initially the cost of adopting BIM may be a little higher, but I think the benefits far outweigh the initial cost in terms of the overall design process, construction process, and also the O&M or the operations and maintenance process. Next slide, please. Right. The next technology, which is catching up very quickly, and I'm sure you've heard of this term called digital twin. It is essentially a virtual model or a digital model which reflects the physical object or the physical model. So you basically create, so there are two parts of digital twin. One is in the design construction phase where you create a digital model of the actual structure, be it a building or whatever, or a plant, and you're able to incorporate all the elements of a real world structure, real world building. And in terms of operations, you can get all the data through IoT sensors and various other methods of capturing data, which helps you to maintain and operate the building properly. So in the near future, there'll be very few buildings with operational issues, as we understand, because of the ability of digital twins to simulate, predict, and take informed decisions based on real world conditions. It can also help you to carry out various kinds of performance analysis. So be it a tunnel, be it a building, be it a plant, be it a oil and gas plant, everywhere digital model twin can be used. Just to give you a little history of digital twin, as a concept, it's not a very new concept. It was essentially a fallout of the Industry 4.0, which was adopted by the manufacturing industry almost 10 years back, and the manufacturing industry adopted the digital twin concept early days, and construction industry adopted it a few years back, driven by some key initiatives driven by the Bentleys and Autodesk and the Siemens of the world. So today, it's become a reality. You can practice digital twin in your design phase, in your construction phase, and in your operations and maintenance phase. Next slide, please. Okay, the next step as we move from 3D and managing the design is 4D BIM, where essentially in a simplistic way, you are able to link your BIM model with your project schedule and be able to do your construction sequencing and monitoring of the project based on the model as to where it should be and where it is. So you kind of do a actual versus planned progress through the actual model, as compared to typically what we do in projects using Primavera, where you have to mentally visualize and there's a lot of data missing. Here you are able to get actual data and monitor the project based on the models and actual work at site. And so basically, it can be used at different stages of a construction project for analyzing design and constructability for better planning and monitoring. And obviously, it saves a lot of time and cost for on-site and off-site projects. Again, 4D BIM as a concept has caught on. Overseas, it's been there since about 2016 and 17. In India, it's been quite prevalent in some of the large infra projects, in airports, in metro projects, in large commercial projects over the last about 2, 3 years. And I think the progressively we are seeing more and more projects adopting 4D BIM as they move from the BIM maturity into 4D. And of course, then we can also talk about 5D, 6D BIM and goes up to 10D BIM. So 4D is essentially where you're able to link the project schedule. So you're able to monitor the project based on time. 5D is you're able to monitor the project based on cost. And 6D is where you bring in the ESG, environment, sustainability, and governance elements. So everywhere we're talking about sustainability, etc. So that's where 6D steps in, and therefore you can manage it better and also cater to the environmental norms. One example of 4D simulation that I found very interesting was a project that Mott MacDonald was doing for a aquatic pipeline project in United States, where just by adopting the 4D BIM, they're able to save almost 20 days of work, in terms of the construction program. Now, 20 days may seem nothing much, but when I look at the productivity and the cost associated with 20 days, and I overlay it on the total project cost, it's the ROI is huge, the value is huge, and that's where we're talking about 4D BIM based construction project management. Next slide, please. So the other technology which is catching up very fast in construction, both from a design and progress monitoring, and of course as built monitoring is concerned, is drone technology, where today you have very high precision drones which can carry very high precision cameras and capture images and deliver data at 10 times faster than traditional methodologies of survey or aerial survey and etc. And you are able to create a 3D digital model using the drone captured images in no time. And you can also integrate that with scan to BIM, where you can, so for example, the outsides and some of the interiors can be scanned through drone, and the details can be captured through scan to BIM. And there you go, you have the complete model for a greenfield project. For a brownfield project, you can also capture the entire as-built model and create 3D drawings, 3D models out of that. And it can also be combined with LiDAR mapping. In fact, now you have LiDAR mapping cameras in drones, which can give you the LiDAR images also, LiDAR-based images also. Next slide, please. So case in example, as you can see, this is a library project in the Middle East, and they had used drone technology to capture the image on ground and compare it with what it actually should be from a model standpoint. This is the 4D BIM-based simulation, and as you can see the date, this was done in 2017, which is like 6 years away, 6 years back. So again, what I was trying to say is drone is nothing new. It's just that we have started doing this in India, and I'm sure we'll go a very long way. And I know a few drone companies who are doing extremely good work in capturing very high precision images, converting that into 3D, and then using that to monitor the projects. Next slide. All right. Next point is laser scanning, or yeah. So basically, you are able to scan and analyze real-world as-built objects. I talked about this earlier, and it can be deployed for on-site surveying, reality capture of existing conditions, construction inspection and verifications, safety aspects, facility upgrades, etc., etc. Very high precision, and can be ingested by 3D tools for forward and reverse engineering, which is basically for greenfield or brownfield projects. Next slide, please. Okay. The other interesting technology that we are seeing catching up very quickly is 3D printing or 3D construction printing. I'm sure you've heard of this concept or even seen it in real life. So you are able to actually create the entire the actual building using 3D printing, and we've seen instances of this in some places in Kerala and Bangalore, etc. So essentially, you are able to use very high precision complex 3D printers to create the entire building or any structure. And basically, it helps you the following benefits. It's you can you can innovate as much as you want to. Wastage is less. This is a huge environmental impact. Production is much faster, which makes it cost efficient. recycling is much better, and there is almost zero to nil human impact. In terms of the market, it's one of the biggest advantages or advances, I would say, of 21st century. The current global market size is about 190 million USD, and it's expected to go up to about 680 to almost 700 billion by in the next 6 to 7 years. And I think the biggest advantage of 3D printing is giving you is it addresses a lot of environmental concerns, besides, of course, the cost and time to construct the buildings. Next slide. Okay. The next point is about IoT and AI. IoT is, as we all know, Internet of Things, and is basically it's able to connect vast amounts of data through sensors or all kinds of IoT devices, and therefore the contractors can easily visualize and the forecast the construction progress based on real-time data, and increase productivity, and the cost can be reduced in a very integrated manner. And AI tools are used, or AI models are used to analyze these IoT data to provide real-time insights. Furthermore, machine learning can be used to create recommendations based on any faults, any defects, or any quality issues. So there is very less human errors, and you are able to address all the issues like materials, scheduling, delay, the reasons for delay, and address those or mitigate those, as well as cost overruns. So you can connect live data feeds from IoT devices to your BIM model and the digital twin, and then leverage that information with AI and ML to create forecasting schedules, cost models, and recommendations. Okay. So finally, what we call the integrated digital delivery, or IDD, which is a concept again catching up very fast, where you are able to integrate all these technologies and see more and more interoperability between different IoT ecosystems and technologies like BIM, digital twin, and cloud computing. Although it is mentioned here near future, I think it's happening now. Next slide. Okay. The other concept that we keep hearing about is VR and AR, virtual reality and augmented reality. Again, this is a huge technology progress in terms of we are moving from using 2D screens with a mouse and keyboard to actually put these VR glasses on, and you can walk around the model in real time with your body, and with your physical movement, you're able to grab digital objects, make the changes, see, do any kind of what if, and see what are the impacts to the design, not just to the design, but also the environment around you. So you can walk through on a one-on-one scale with these through this AI and VR models, and you're able to compare details, record any differences directly into the model, and measure real-world objects. So any changes that you make to the model, any new task or resource statuses, are added directly to the model using this technology. And in fact, it's a $8 trillion global forecast in the next about 5 to 6 years. It is estimated to bring down cost of building by 90%. The biggest advantage is remote site inspections, paperless remote site inspections, especially for projects which are in far-flung areas, very difficult to access, and guys sitting in the office who are part of the design team or construction management team can actually see this in almost real time and do whatever analysis that you have to do. And of course, that helps you to ensure that safety of your workers, better collaboration amongst all the stakeholders, and communication across the entire ecosystem of the AEC teams. Next slide. So to sum it up, I think we are talking about an entire digitalization roadmap, and people across the world, and definitely in India, are at different stages of this roadmap. So if you see the x-axis, it's level 1 to level 5, and y-axis is where you have the various technologies which are adding to your or adding value to your entire project. So typically 2D, 3D, BIM, and also using photogrammetry, and also using project management tools like P6, Asta, MSP, etc., is where you are in terms of the level 1, which is, I think, most of us are today. Level 2 is where you move from there to 4D BIM, 5D BIM, then digital rehearsals, schedule improvement, complete digital project management, model-based training, planning, and best practices, etc. Then you move to level 4, where you talk about CNC fabrication, digital printing, digital field, 3D printing, digital field planning, then model-based production tracking, and the supply chain, which can be completely digitalized. And of course, using your Power BI, you can create dashboards and controls on your screen. The level 5 essentially is the highest level of maturity as we see it today in terms of being able to do complete immersive reviews of the project's digital inspection, digital completion and handover, and of course the time lapse and camera integration. So these are the different stages, and one can plan to get there. It may sound very overwhelming. So I think my recommendation is that as we talk to different customers and clients, is that take one step at a time, but plan for the entire progress, because these technologies are here to stay. And I think we better adopt it fast as we can, which will help us in doing our projects better and also making our customers very happy. So that brings me to the end of my presentation. And we have a Q&A session at the end. So if you have any questions, just make a note and reserve it for the end of the session. Thank you.